Hi guys, welcome back to our YouTube channel CDA Math. I'm Anya.
I'm Anna.
And I'm Anna.
And today we're going to be learning about the mathematical concept of variable separable and reducible to variable separable.
For more videos, subscribe to CDA Math, like, share, and comment down below.
Let's discuss differential equations. So a differential equation, it is an equation with an unknown function and the derivatives of it. It represents the relationship between the variable, the function of the variable, and the rate at which that function is changing. Now, differential equations, it has many applications. It comes in engineering, biology, economics, etc. So it comes in different fields. There is order of the differential equation, which is the highest derivative present in that equation. And the degree, that is the power of that highest derivative, is the degree of the differential equation. Let's come to an example. So d square y by dx square plus 6 dy by dx plus 5 is equal to 0. Here our order, that is the highest derivative present, is 2. So our order is 2. And degree, that is the power of this derivative, is 1. That is why the degree of this differential equation is 1.
Okay, now that we know the different methods to solve a differential equation, let us focus on the first method, variable separable. Let us take an analogy. So, suppose you have a bowl of M&Ms of two colors, blue and green. You separate the blue M&Ms in one bowl and green M&Ms in another bowl. In a similar way, in a differential equation, when you separate y terms to one side and x terms to one side, it is an example of a variable separable equation. Let us now understand the general form of a variable separable differential equation. So, dy by dx is equal to f of x and g of y is the normative form in which you can identify that, okay, I have to use variable separable in this differential equation. Now, the steps to solve, we will understand the steps to solve a variable separable differential equation. So, now for the steps of the variable separable form. So, in step 1, we have the equation in the form of dy by dx is equal to f of x into g of y. Now, in step 2, we're going to transpose f of x, we're going to transpose d of x into this side and g of y to this side. So, the y terms are on the left hand side and the x terms are on the right hand side. So, this will be represented as g of y into dy is equal to f of x dx. Our next step is to integrate. Step 3, integrate. So we will integrate g of y with respect to y and integrate to integral of f of x with respect to. The most important part in solving an equation by variable separable form is to make sure that you add plus c in the answer. Okay, now we have a fairly simple question on variable separable. We can identify that this question is in the form of variable separable since dy by dx is equal to f of x into g of y. So our first step is moving y to our left hand side and all the next terms to our right hand side. So let's do that. Y dy is equal to minus 2x dx. Our next step is to integrate both sides. So integral, it's 1 by y. So 1 by y dy is equal to minus 2 integral of x dx. Minus 2 is a constant, hence it is taken outside the integration sign. So integral of 1 by y is log y is equal to minus 2 x squared divided by 2 plus c. So our final answer comes out as log y plus x squared is equal to c. This is okay. Now for our second question, we have a slightly more complex question since dx has both x and y terms and dy also has both x and y terms. You might think that this question is in another form, which is not variable separable. However, it can be solved with the form of variable separable as well. All you need to do is just transpose this to the right hand side of the equal to sign. So, cos x 1 plus cos y dx is equal to sin y 1 plus sin x dx. Now, we know that all the dx terms, all the x terms have to be this side, and all the y terms have to be this side. So, we're just going to move them around. So, cos x divided by 1 plus sin x dx is equal to sin y divided by 1 plus cos y dy. Our next step is to integrate both the sides of the equation. So, okay, now in order to solve this integral, we have to use the substitution method. We have taken 1 plus x as b and 1 plus cos y as n. Once you differentiate 1 plus sin x, you will get cos x dx, which is basically our numerator over here. And on differentiating 1 plus cos y, you get 1 plus sin y, which is our numerator over here, which is also our numerator here, just without the negative sign. So this will make our integration simple. So now let's go ahead and continue. So it becomes dt divided by t is equal to minus integral of dl divided by m. Now this is log t is equal to minus log m plus log c. Let us keep in mind our properties of logarithms. So on taking log m to this side, you will get log t minus plus log m is equal to log c. Log a plus log b is log a into b, so that is a log t into m is equal to log c. Now we can cancel out the logs. So our final answer ends up being Pm is equal to C. Now we substitute P and M back in this equation. So it's 1 plus sin x into 1 plus cos.
An equation that is given to you might not directly be variable separable, but you can reduce it into a variable separable form. So let's take an example of shirts and pants. There are a lot of outfits that are sewn together. So now, if we want to separate the shirts and the pants from each other, we can cut it. So here let's use the cutting as an equivalent to substitution method. Okay, so if we're given an equation that is of the form dy by dx is equal to ax plus by plus c. Now, not directly we might not think of it to be a variable separable question, but it can be reduced to a variable separable form. So here we can substitute this whole thing as b. So that will be our step 1, where we make ax plus by plus c equals to t. For this, what we do is we differentiate this entire equation with respect to x. So we are left with a plus b by dy and dx plus 0 is equal to dt by dx. So this is our step 2. So now our next goal is to get dy by dx from here so we can replace it back into this equation. So what we get will be dy by dx is equal to 1 by d into dt by dx minus a. This will be step 3. So now since this entire thing is equal to t, as we previously mentioned, dy by dx also equals to t. So we can replace here t will equal to 1 by d into dt by dx minus a. Now we can bring b on the other side and we're left with dt is equal to dt by dx minus a. When we bring a on the other side, we get dt by dx is equal to dt plus a. And then we can move this part of the equation to this side and move dx on this side. So we would get dt divided by dt plus a is equal to dx. So after we bring dx on this side and we move dt plus a on this side, we can see that all the t terms are on one side and the x terms are on one side. So we have brought it to a form where it is in variable separable. So now we can simply integrate both the sides and we can find the answer. Okay. So now there are various strategies that you can use to reduce it to a variable separable form. So the first thing that you would need to do is identify the table and where the variables are mixed and what you can substitute to a random other variable like a t, u, v, whatever you want to choose. Then after that you perform the substitution and you find a new derivative for it. And then you have to replace that derivative in the original equation with the new variable that you have assigned to the entire term. After that, you have to make sure that you remember to substitute back the value of the original substitution that you have given. So if you have taken t is equal to ax plus by, then you have to remember to replace the value of ax plus by in place of t in the final answer. Okay, so now let's understand this with an example. Here we can see dy by dx is equal to 4x plus y plus 1 the whole square. Now this does not directly look like it's variable separable, but it is. If we substitute this entire term as t, we can see how it will get reduced to a variable separable form. So our first step would be making this equal to t. So 4x plus y plus 1 is equal to t. Then our second step would be to differentiate it with respect to x. So we get 4 plus dy by dx is equal to dt by dx. Now since we have to replace dy by dx in the equation, we move the 4 on this side. So we get dy by dx is equal to dt by dx minus 4. Now we replace dy by dx in this equation. So we get dt by dx minus 4 is equal to, since we have replaced this with t, we can make this as t squared. Next what we can do is we can move the minus 4 on the other side. So we get dt by dx is equal to t squared plus 4. Now since the right hand side has a t term, we can bring it to the left hand side with dt and dx on the right hand side. So we are left with dt by t squared plus 4 is equal to dx. Now what we have to do is integrate both the sides. So now the integral of t 1 by t squared plus 4 would be 1 by 2 tan inverse of t by 2 is equal to the integral of dx, which is x, plus c. Now here we must remember to substitute the value of t back into the equation. So we get 1 by 2 tan inverse t here is 4x plus y plus 1. So 4x plus y plus 1, 4 divided by 2 is equal to x plus c. This would be our solution for this differential equation. So here's an example. This does not directly look like it's variable separable, but it is. So it might look a little complicated, but let's simplify it. So here we can make dy by dx is equal to sine of x plus y. We basically move the sine across on the other side. Now what we can do is we can x plus y as t. And then what we do is we differentiate with respect to x. So the level 1 plus dy by dx is equal to 0. which implies that dy by dx would equal to dt by dx minus 1. Now we can replace dy by dx with this new thing that we found back into the equation. So we get dt by dx minus 1 is equal to sin t, because we took x plus y is equal to t. Now what we can do is we can take this minus 1 on the other side. So we get dt by dx is equal to sin t plus 1. Next what we can do is we can bring sin t plus 1 in the denominator of the left hand side and move dx to the right hand side, and we will be left with dt divided by sin t plus 1 is equal to dx. So we can integrate both these sides, but here we cannot directly integrate sin t plus 1. So what we do is we will multiply the numerator and the denominator with 1 minus sin t. So what we get is dt into 1 minus sin t whole divided by, when you multiply 1 minus sin t with 1 plus sin t, you will get 1 minus sin square t is equal to integral of dx. Now 1 minus sin square t can also be written as cos square t. And since our numerator can be separated into two parts, we're going to do that so that it's easier to integrate. So we are left with 1 minus cos square t dt minus integral of sin t divided by cos square t dt is equal to integral of dx. Here, this is simple. It becomes the integral of sec square dt, which is basically sec square t dt, and this will become the integral of tan t into sec t dt is equal to integral of dx. So the integral of sec square t dt would give us tan t, and the integral of tan t sec t will give us sec t is equal to the integral of dx, which is x plus c. Now we have to remember to replace that with the value of t, which we are taking as x plus y. So it becomes tan x plus y minus sec of x plus y is equal to x plus c. And this will be our final equation for the equation.
So at times we cannot solve by using variable separable. So there are other methods to use. This is homogeneous differential equation, which is represented in the form dy by dx is equal to f of y by x, or dx by dy is equal to f of x by y. It is the function of the ratio of two variables. After we check whether it is homogeneous, we put y is equal to dx and x equal to by, and then we differentiate it with respect to x, which we get as b plus x dt by dx. Now, in all cases, we do not have it in the homogeneous form, so we can reduce it to homogeneous. That is represented in the form dy by dx is equal to ax plus by plus c divided by capital AX plus capital By plus capital C. Here we have two different cases. The case one is when A by capital A is equal to B by capital B. In this case, we take AX plus By equal to B. And then we solve it by normal homogeneous form. Then in case 2, when A by they are not equal, then we put our X and Y as capital X plus H and capital Y plus K, and then we differentiate. We put it dy by dx equal to ax plus dy by capital AX plus capital AY, because our constants are all equated to 0. Then after doing so, we have it in our homogeneous form. So just like normal, we will write y is equal to dx and then differentiate. Another way to solve a differential equation is by using the linear method. It is an equation is linear if it is in the form dy by dx plus p of dy, where p is a function of x, which is equal to q of x. Now when we have it like this, then the integrating factor is e to the power integration of b. And then when we get this integrating factor, we multiply it with y, which is equal to the integration of q into the integrating factor with respect to x. Then similarly, it can also be in the form dx plus dy plus p, where p is a function of y, into x, which is equal to q, which is also a function of y. Then here, the integrating factor will be e to the power integration of p dy, which is equal to x into integrating factor, which is equal to q into integrating factor dy. Now the reason why this is called a linear differential equation is because p and q are only functions of x or y, or their constant.